Okay, so we are going to do lesson 4.5, which is proving triangles congruent by ASA and AAS. We've already proven triangles congruent by SSS and SAS, so this is just adding a couple more to our toolbox that we're able to use. Just like last time we had an included angle, which was the angle in between the two sides, this time we're going to have an included side, which is the side that's included between our two different angles. And this is going to get us ASA. So ASA is, of course, angle side angle congruence. And that is where we're going to have one set of sides and two set of angles, but the side has to be that included side. So the side has to be touching both of the angles in order for our two triangles to be congruent. Remember to mark all your information on your triangle and look out for those vertical angles that we've been working with. And you'll also have reflexive property. So far we've used reflexive property for sides. Starting today we'll also be using it for angles. And then remember we've used some parallel lines. They can show us that angles are congruent, or they can show us that angles are supplementary, depending on whether they're consecutive interior, alternating interior, corresponding, etc. Okay, so L is the midpoint of WE, and that's the first given we have. So if we look at that, L is the midpoint of WE. We know because it says midpoint that we're going to be using the definition of midpoint. And that definition of midpoint tells us that our two sides are congruent. So we know that WL is congruent to LE, and right there we have one set of S's. It also tells us it also tells us that WR right here is parallel to ED. So if we kind of extend our lines there, right, just because they're parallel doesn't mean they're congruent. So we can extend our lines and see what it tells us. And we know that it gives us these sets of angles right here, angle W and angle E, or we can name those with 3 letters. We don't have to. It tells us those are congruent because they are alternating interior. So by the alternating interior angle theorem. So that gives us a set of A's. So now we have a set of A's, set of S's. We either need another A or another S. But because this is the bow tie shape, we always know that we have our vertical angles. Remember, instead of vertical angle theorem, you can say that vertical angles are always congruent. And those we will have to name with 3 letters, because if I say angle L, that could be referring to any of the 4 angles in the middle. If I say angle RLW, I'm going to say angle DLE. And so that gives us another set of angles. Now over here it says SAA, which isn't really a thing. Remember, this doesn't always have the right order. It just tells us that we have 3 things. We're going to need to look at our for the order. So I have this side, this angle, and this angle. This side, this angle, and this angle. I can mark it. I have an ASA. On both sides, my S is touching my A, so my triangles are congruent by ASA because I have that included side on both sides of the triangle, so both sets of triangles. Okay, so now we have another one with parallel lines starting off. AB is parallel to CD, and that's already marked for us. I'm just going to extend it so we can kind of see what's going on there. And we have our transversal again. So if you notice, we have these alternating interior lines again. Alternating interior angles using our parallel lines, and those are always congruent. So here I can't say angle B and angle C because that could be referring to either one of those angles. So I'm going to name it with 3 letters. I'm going to say ABT is congruent to angle CDB. And that gives us one set of angles. Then it tells us another set of lines are parallel. Again, I highly recommend you mark it with colors. I think that's helpful. And so because of that, we also know we have alternating interior, but this time with a different set of angles. Every time you have parallel lines, it doesn't mean there's alternating interior angles, but that's a good place to start. So again, I'm going to have to name them with 3 letters. CBD and ABB. And there we go with another A. So now we have 2 of the 3 things we need to prove congruent, because if we're using a shortcut, we'll always need 3 things. So now we just have to look, and because we have these 2 triangles attached, they are sharing the side that is reflexive. And so we know that BD is congruent to DB. Of course, we've talked about that reflexive side a lot. And so that gives me an S. Again, I got to actually look at my figure to see the order. I have an angle, and the side in the middle, which is included. Angle, and the side in the middle, which is included. So these triangles are congruent at ASA. So that's the first half of this is ASA. And then very similarly, we have AAS, which means I have an angle side. So I'm still going to have 2 angles and a side. The difference is where it is. So I still have 2 sets of congruent angles, but this time it's going to be a non-included side. So if I label these, my S right here is only touching 1A, not both of them. That's the difference. It's a non-included side. So let's try this. And of course, we're going to mark our figure. So it tells me that in KL, this angle up here is congruent to NJM. So that gave me a set of angles. You can see, hopefully you can see our 2 triangles here it's talking about. We have a triangle here and a triangle here. So kind of keep that in mind. And then it tells us KL. So this line here, this whole line, so I'm going to mark it like that, is congruent to JM. You can put a hash mark on it. It's just kind of hard to tell that we're talking about that whole angle. Okay, so that gives me a side. Okay. And if it helps, which often it does, to separate the figures, that's a good idea. So I'm going to draw my right one, L and K, and we had marked that congruent with the one facing left, L and M, and that J was congruent to K, and then that JM was congruent to KL. So we have an A and an S. Now we have a reflexive property. So this is a new thing. We've done reflexive before, except this time they're not sharing a side. They're actually sharing this angle in right here. So this angle in, you can see, is on both triangles. And it's probably easier to see in the original picture, but it actually makes its way on that triangle and that triangle. And so they actually share that. And you can name it with 3 letters if you want, but because it's the only angle there, you don't have to. So that actually gives another angle. And we can look over here. We have an A, an S, and an A. Our S is not touching both A's, so it is not included. So when I write my statement, my S should not be touching both A's. It's in the same order. So again, my S is not in the middle of my A's, so it shouldn't be here. So AAS proves my triangle is congruent. So if I say JMN, you would say ALN. And now all that I know my triangles are congruent, I can always go on to prove a side or an angle using CPC. That's how many parts of congruent triangles are congruent. So remember, anytime you're proving any sort of triangles congruent, you're going to be using one of your S's and A's, which are SSS, SAS, ASA, or AAS. And then if you need to go a step farther to prove lines or angles congruent, you'll do that using CPC. Okay, one more. I would like for you to pause this and work this on your own, and then check back and unpause it and check with the answer I put up. Okay, I've completed my proof. I had my givens, and that gave me, I drew my figures separately. It gave me an angle, and it gave me a side. Then I looked for what was reflexive, and they shared this angle A up here. So that gave me another angle. So now I have three things. I have two angles and a side. I can prove my triangle's congruent. My S is not touching both A's. So we know that it is AAS because it's a non-included side. And now that my triangles are congruent, I can go on to prove another set of angles congruent by CP/CTC. Notice this is AAS. If you say SAA, that's the same thing, but this is actually the name. So anytime you have all the others are, you can say forward and backwards, and they're the same way. This is the only exception to that. Make sure you learn it as AAS. So this is just a review of what all we've learned, plus a new one. We have the three S's. SAS, where the A has to be in between the two S's, it's the included angle. The ASA, where I have two angles and an included set of sides, or two angles and a non-included set of sides. These are your four ways to prove triangles congruent. But there is actually a fifth. This is the one exception to where we said we can't spell a bad word. This is hypotenuse leg. This only works on right triangles, because that's the only kind of triangles that have a hypotenuse. Remember, your hypotenuse is always across from your right angle. So if I know I have a right angle, it has to be a right angle though. And if I know I have a hypotenuse, which is a side, and if I know I have a leg, which is the side, it does follow a bad word. This is the one exception. It would be, hypotenuse leg, because we have our legs and our hypotenuse. Okay, so that's one exception. The only exception to the ASS rule not working is if it's a right triangle, so that it's HL. So these are the 5 ways you can prove triangles congruent.